Imagine every app on your computer sealed inside its own shipping container, safe, portable, and ready to go anywhere. But what happens when you want to run 100 of them across the globe, all at once? Most people know Docker makes apps simple to move, but few realize why Kubernetes is now essential for running them at scale. Once you see their hidden differences, picking the wrong tool can cost days or even weeks of wasted effort. So, what actually sets them apart, and how do you pick the right one? Docker packages an application and everything it needs, including code, libraries, and settings, into a single portable unit called a container. Think of it as a standardized shipping container for software. No matter what's inside, you can load it onto any compatible ship, truck, or train, and it will work the same way everywhere. Kubernetes takes this a step further. Imagine a bustling port, not just moving one container, but managing thousands at once. Kubernetes acts as the port's logistics brain, deciding which ship should carry which containers, when to load or unload them, and how to reroute if a ship runs into trouble. While Docker is the box that keeps your app safe and consistent on its journey, Kubernetes is the system that coordinates fleets of boxes across the globe, scaling up or down and keeping everything running smoothly. This shipping metaphor makes it easy to see how Docker and Kubernetes fit together. One creates reliable containers, and the other orchestrates their movement at scale. A Docker file lays out each step to build an application image, the base environment, required libraries, and the command to run. When you build the image, Docker bundles everything into a single unit. The command, docker run -d-p80:80 nginx, starts a web server in the background, linking port 80 on the host to port 80 in the container. The container shares the host kernel, yet stays isolated from the rest of the system. Kubernetes shifts the focus from single machines to clusters. Instead of running commands, you declare your intended state. Using kubectl, apply -fdeployment.yaml. Kubernetes creates or updates pods, each running a copy of your container. It manages scheduling and scaling and keeps everything as described. Whether 3 or 100 replicas are needed, Kubernetes maintains them. This marks the step from managing containers locally to orchestrating them across multiple machines. Ready for a quick challenge? Grab 20 seconds. If you can, open a terminal and type docker run hello world. Hit enter and watch what happens. That single command asks Docker to pull a tiny test image from Docker Hub, spin it up as a container, and print a success message if everything is working. It is the fastest way to check your setup and see a real container in action. If you see the welcome message, drop a comment with hello world worked, or tell us what you saw, errors included. If you are watching on mobile or do not have Docker installed, no worries. Just imagine that command checks containers running on your own machine, not in the cloud or across a cluster. In a moment, we will see how Kubernetes takes this idea and stretches it across fleets of machines. For now, take your shot at the challenge, and let us see who is up for it. Running containers on a single machine is simple. Docker uses one background process, the Docker daemon, to manage everything locally. But as soon as you need to run containers across a cluster, complexity rises fast. Kubernetes introduces a multi-part control plane, including the API server, the scheduler, the controller manager, and other components, each with its own job. Managing all of these yourself means handling upgrades, scaling, and security patches. That is why cloud providers offer managed Kubernetes services, like Google Kubernetes Engine, Amazon Elastic Kubernetes Service, and Azure Kubernetes Service, because they host the control plane so you can focus on your apps. Under the hood, Kubernetes now relies on runtimes like Containered instead of the older Docker engine. This shift, known as the Docker shim deprecation, means Kubernetes clusters no longer need Docker itself to run containers. Docker-built images remain fully compatible. For teams, the trade-off is clear. Local Docker is lightweight, while Kubernetes brings power and flexibility, at the cost of operational overhead, unless you let a managed service handle the heavy lifting. Choosing between Docker and Kubernetes depends on what you actually need to do. If you are building or testing an app on your laptop, or running a small project on a single server, Docker alone is usually all you need. Simple, fast, and easy to manage. For large production systems with many services that need to scale automatically, recover from failures, and balance traffic across many machines, Kubernetes is the right tool, especially if you use a cloud provider's managed service. Most teams combine both. They build images with Docker, then deploy and run them at scale with Kubernetes. Start simple and only add complexity when your project demands it. A lot of hype surrounds both Docker and Kubernetes, but neither is a silver bullet. Kubernetes won't magically fix a bad app or run everything for you, and Docker alone does not solve scaling or reliability. It helps to know where these tools come from. Docker began as an internal project at .cloud, where founder Solomon Hykes wanted a better way to isolate applications. He introduced Docker at PyCon 2013, and it quickly took off because it made containers easy to use. Kubernetes traces its roots to Google's internal system called Borg, which orchestrated billions of containers a week, long before Kubernetes was open sourced in 2014. That Google pedigree is part of why Kubernetes became trusted for large-scale operations. So, while Docker and Kubernetes are powerful, they are built on years of real-world experience, not magic. Today, every tech team faces the choice between simplicity and scale. As cloud-native demands grow, mastering these tools isn't optional, it's essential. The future of deployment is already here. Share your perspective below. I hope you found this video helpful, and I hope to see you in the next one as well.